Okay, thanks for joining today, everyone. Welcome to today's webinar on Tolerancing 101. This is going to be a quick 10-minute webinar. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I'll be moderating today's webinar. Presenting today is Tim Mao, our Applications and Technical Support Manager. Just a few quick things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. Due to the shortened length of today's webinar, Tim will only have time to answer about 3 questions based on what's most frequently being asked. If we don't get to yours, we'll have someone follow up with you afterwards. Finally, this webinar will be recorded and we'll send you a link to review it afterwards. So with that, I'll turn it over to Tim.
Thank you, Robert. So we're going to dive right in. We're calling this Tolerancing 101, and as Robert said, we're going to try and do the presentation part in 10 minutes, so here we go. So we're going to start with talking about exactly what a tolerance is, just to make sure we all understand what we're discussing here. So the definition of the word tolerance I've got up here. It can mean a few different things. There's a few different forms of the word, but of course we're looking at the one identified by Merriam-Webster is number 3, the allowable deviation from a standard. In other words, how much difference can I be, how far off can I be from what I want? From a color perspective, it boils down to how much difference is okay. And where does that determination of how much is okay come from? Well, it's always customer defined. Even if the customer that you're selling to doesn't tell you this, right? They are ultimately defining it. And what I'm trying to get to is that we as consumers, when we go to purchase things, make decisions about whether things are good or not, right? Most customers of ours, we can ask them, can you look at a sample and tell me if that sample is good or bad based on its color? Just by looking at it. And if you can, then that's a form of a tolerance. You can define how much difference is okay. So we get lots of inputs about that, though, from various places, like the customer who says, well, here's my standard, just match it. Or make the delta E less than 2. Or you hear things where the customer says, I'm not buying that because it doesn't look good. And that's all they tell you, right? Or it looks great. Or it's washed out, and you start getting weird words describing what's going on. Or hopefully you get lots of this. It's exactly what I wanted. Or they say, yo, use specification ASTM, blah, 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 right? There's lots of different ways for people to describe tolerance. We're going to talk specifically about the colorimetric numerical tolerancing that we use when we do color measurement. So color tolerancing can be done with a large variety of methods, and agreement to that visual is absolutely key and critical because, let's face it, your customer could agree that you're going to have some numerical tolerance. Let's say it's 1.0 whatever. Yet if you give him a sample that's at 0.95 that looks bad, he's still going to reject it because he's still going to look at it. So it's got to have some agreement to visual. So we do have people who are doing a visual only tolerance. That of course gets difficult because two different people see color differently. There's lots of drawbacks to visual, or people under the right lighting and all those kinds of things. But there are tolerances that are done visually. In some cases, people even have a color standard, and maybe they have a sample. They say that this is my light limit, so it can't be any lighter than that or any darker than this, right? That can be done visually. We're going to focus the rest of our time, though, on these. So LAB can be used as a tolerance, and we're going to talk about a bunch of different color spaces here. We have other resources, webinars we've done in the past that you can get recordings of, other resources that we have available on our website to dive more deeply into these. We're not going to do that today. We're just going to focus on the fact that there are different ways to do it. So we have LAB, we have LCH, and we're showing you how these plot in our IQC software. We can do straight what's called CLAB delta E, or we can do an elliptical tolerance like delta E CMC, delta E94, delta E2000. Now, the percentages in parentheses behind those is an indication of some testing that was done that says how often does this tolerance, if I use it to determine pass-fail, agree with visual pass-fail. You can see as we've progressed down the list, the elliptical tolerance is at 95%, and some of those are even tweaked to do higher percentages than that, give the best agreement with visual perception. So if you ever ask us at X-Rite, what would you recommend as a tolerance type, we're always going, almost always, I will say that, drive you toward an elliptical type tolerance because of the better agreement with the human vision. The reason I say almost always is there's always exceptions to the rule. All right, so let's assume we've selected an elliptical tolerance. We're going to move on. Now comes the hardest part. Okay, how big is the tolerance? What number at what number do I go from acceptable to unacceptable? And that can be done very easily. You build the tolerance on real samples. Now, in some cases, you may have a customer who comes to you and tells you, I need you to make this for me, and this is my tolerance. And they give you the number and everything. I mean, you're pretty much set. You just go with that. But if you don't have that, or you have to set your own tolerancing, do it on real samples. And what I mean by some that are good and some that are bad is visually do an assessment. You've got a color standard, do a visual assessment, make 2 piles of samples. This pile of samples, these all look good. This pile of samples, these look bad. All right, then we're going to, as I say, base them on visual assessment or even customer approval, and then measure them. Okay, so we might measure them in, and I just put in a default tolerance of 1 unit in this case, delta ECMC of 1.0, and I said make everything pass or fail based on that. And I got 4 that failed. They've got red X's next to them in their trial name here, and I got 2 with green check marks. But if I go back to my visual assessment, the reality might be that sample number 0001 and sample 0004 look okay to me, okay? And I actually want to accept those. But sample 2 does look bad. It's so much darker, 2.7 units, that it doesn't look good. And sample 5 really doesn't look good because it's 2.2 units yellower than my standard. So those indeed I want to fail. So 1 isn't the right tolerance because I'm failing some things I don't want to. So what do? Well, I can change that tolerance. And if I change the tolerance to 1.05 instead of 1.0, now I can make it so that my samples that look good visually pass, that look bad visually fail. Now, realize that I used a pretty easy example here, and it doesn't always work that way. You might have some samples with lower delta ECMC that are bad, and you have higher ones that look good. So there's some adjustment and work that has to be done there. But by measuring samples, you know visually that they pass or fail. You can build a tolerance then that will agree with that. And that's what you're after. You want to be able to take a measurement and rely on the fact that when it says it passes, that you and your customer will also say that it passes visually. So we establish a tolerance like that, then we've got to make it actionable. Because the difference between good and bad is not a knife edge. In other words, 0.99 with a tolerance of 1, 0.99 is not as good as 0.01, right? 0.99 is getting really close to failing. So we want to set the tolerance to alert us when we're drifting toward failure. And so our software allows us to put in what's called a margin. So if my tolerance is 1, I can set it so that the software will alert me when I get close to failing. Okay, might say, oh yeah, you're within 10%. And it looks like this. So my tolerance is 1. Anything between 0.9 and 1 is going to be labeled with this yellow question mark. And you can see graphically, I've got this yellow area in my scatter plot. Those things are in the margin, meaning you're getting close to failing. If I'm looking at a run of production, I better change something because I'm going to start failing. The other thing it does is it tells me any green check marks I get, I don't really have to do anything else with those because I know they're good, because not only do they pass the tolerance, but they're also a long ways away from failing. So this gives us kind of an action plan, right? If I set that percentage wherever I want it for my warning level, green check marks mean keep doing what you're doing. Just keep on making it. Let's save time and keep going, right? If I get yellow question marks, oh, pay attention so that you can fix a problem before it becomes a red X, where you've got product that literally failed. Okay, and then the last thing we're going to talk about is, if necessary, use an internal tolerance in addition to a customer one. And as an example, you can do things by tolerancing both an elliptical delta E tolerance and something like delta LAB. And the reason you might do that is your customer might tell you, here's my tolerance, it's 1.0. But as I mentioned earlier, we all know a customer will tell you what the tolerance is, but they're ultimately still going to reject things if they don't look right. And they might tell you their tolerance is 1, but the reality is if they reject anything, in your experience with the customer, you find they reject anything less than 0.9 or greater than 0.9. And so you can put some actions in place so that you protect yourselves from, yes, we're always going to meet their specified numeric tolerance, but we're also going to meet their visual tolerance. And you always want to be able to look at things like delta LAB, or if you prefer LCH, because tolerancing with an elliptical tolerance gives me a pass or a fail, right? But when I'm 1.99 units in delta ECMC, okay, it fails, but why? Is it too light, too dark, too red, too green, too yellow, too blue? I don't know that from this number 1.99. I need to go over here and look. Oh, that sample is 2.81 units lighter and 1.75 redder. Yes, it's got some, and 1.5 yellower. It's got some significant issues. Now I understand what direction I'm off, which may give me a clue as to what I need to do to fix it. Okay, so in combining those things, we end up with a tolerance type that agrees with your customer's assessment of your product and meets their needs. That's the key, first key. Second one is to use margins to alert you when you're starting to trend towards failure, should that happen. And then lastly, you want to use the three-dimensional color metrics like LAB or LCH to help direct you in correcting a color issue. Because just putting a tolerance in place doesn't suddenly make your color better, right? Putting a tolerance in place just starts to identify and notify you when you have color issues. And then what do you do next is really key, right? What do I go fix when my color is wrong? All right, I think we did it in about 10 minutes, maybe a minute or two long. So questions, I'm gonna go take a look over here at the question panel. So I see one question was asked about is the 10% margin based strictly on delta ECMC? The way our software works is that margin of area that's going to be labeled as warning is a percentage of whatever tolerance type you use. So any of the tolerance types I mentioned could be delta LAB, delta LCH, delta E, any of the elliptical tolerances. It's simply a percentage of that. So the easiest one, of course, is if the tolerance is 1.0 something, then we can say, okay, well, within X percentage of, if I set it to 25%, then anything up to 0.75 would be pass. From 0.75 to 1.0 would be margin, and over 1.0 would be fail. All right, let me take a quick peek here at the questions again. Another question, how's LAB different from LCH? So the reality is that LAB and LCH are derived from the same thing. I mean, all of it's derived from the same basic calculations, right? But LAB uses, and I'm gonna actually, in my slides, go back up a minute. LAB uses, if I can get to it, there we go. You'll notice we've got axes in the plot, a horizontal and a vertical axis. And you'll notice that the tolerance is a box where the sides of that box are always parallel and perpendicular to the axes. So LAB is like using Cartesian coordinates, X, Y, and Z to plot something, okay? LCH is based on the fact that hue, which is the H, our hue is in a circle, if you will, okay? And chroma, the C, is how saturated is the color. And so it's a measurement of how far away from the center of color space it is. So you'll see, based on what color you measure, that this box now is no longer perpendicular and parallel to those axes, but it's rotated. So LAB is Cartesian kind of coordinates, length, width, and depth, X, Y, Z. LCH is more like polar coordinates, right? Longitude, latitude, and altitude. So that's the difference between those two. Okay, let me find here one more question. We've got lots of them, and we do promise we will reach back out to you. So we'll answer this one. Can I put a tolerance on delta LAB, not just delta E? Yes. All of those things can be toleranced, and quite honestly, one of the advantages, and this is where I said there are some examples where I might not use an elliptical tolerance. There are situations where your customer gives you a standard, but the color standard they give you, they might say, here's my color standard, but I want you to always make it redder than this. Don't let it be any greener, right? Or always be, this is the color standard, but I don't ever want it any darker. Well, you can't, with elliptical tolerancing, the standard's always going to fall in the center of the tolerance. With LAB and LCH, we can do something called asymmetrical tolerancing. So I might be able to build a tolerance in LAB that says the maximum delta L in the negative is 0, meaning it can never be darker, but it can go as much as 2.5 units lighter, right? It can never go negative A, so it can't be any greener, but it can go 1.5 units redder. So LAB and LCH give us the ability to do this asymmetrical tolerancing, which is helpful when you have a customer who says, like I mentioned earlier, this is the basic color that I want, but I want it off in this direction all the time. Then you can tolerance that way so that it forces you to produce color in that direction. All right. I think I'm going to answer one more question. I'm in control here. They're going to let me do that. I'll do it. So somebody asked about a typical delta E for powder coating application, or the question could really be, what's a typical delta E for any application? Reality is that those numbers vary greatly. It depends. It depends on your customer, right? If I'm coating, let's say I'm powder coating something that's going and being assembled into a toaster oven, and the part I'm powder coating is going to be adjacent to a piece of plastic, and those two things need to match, I'm probably going to have a pretty tight tolerance, because I am going to have some variation, and the plastic piece is going to have some variation. When I bring them together, I want them to look like the same color. My tolerance needs to be fairly tight. If what I'm powder coating or painting or molding out of plastic is the full enclosure of that toaster oven, my tolerance can probably be a little bit looser, because I don't need to match an adjoining face or facet, right? And the customer may accept more. At X-Rite, we deal with people in many different industries. We deal with people in automotive industry who typically have tolerances in the 0.5 to 0.8 region, 0.50 or 0.80. We also deal with printers who many times are told their tolerance is 3.00. Well, that's like 6 times larger than the automotive tolerance. So a lot of it has to do with those kinds of things. Is what I'm producing going to be, in a very tight proximity to something else that's supposed to look the same color, or is it going on a bread package, which, yeah, we want all the bread packages to look the same, but the reality is that the color is not as critical there. So those are conversations and things that you got to work through with customers to try and understand the best way to do that. All right. With all of that, we thank you for all your questions. As Robert and I both stated earlier, we do promise to reach back out to any of you who submitted questions to provide you responses on that in the next week or so. We will make sure we get that done, as well as the recording of the webinar will be made available to you coming up shortly as well. With that, I thank you all for your time and attention, and I hope that you have a very good day.
Perfect. Thank you, everyone.